Hi all, this is Shweta Reddy working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. Here in this video of wireless communication, we are going to see about shadowing and fading. So we have seen some basic terms in wireless communication in the previous video. Some of the terms we have seen is first one radio propagation. What is radio propagation? Radio propagation is nothing but the tendency of radio waves traveling from one point to another point in the various parts of the atmosphere. And we have also seen the modes of propagation. There are three modes of propagation. First one is direct propagation. Second one is ground wave propagation. The other thing is sky wave propagation. Direct propagation is that is without any reflection, diffraction or scattering. The signals will be reaching the receiver from transmitter directly. That is, it is also called as LOS or line of sight propagation. The second one is ground wave propagation. When the distance between the transmitter and receiver is increased, the signal will be reflecting on the ground and reaching the receiver. And the third one is sky wave propagation. Sky wave propagation happens when the EM waves hits the ionosphere layer. It will be hitting and reflecting back to the receiver. So these are the three modes of propagation. And we have also seen about multipath propagation. Multipath propagation happens when there are more obstacles present in between the transmitter and receiver. If there are more number of obstacles, there will be more number of signals reaching the receiver. Since these signals are taking different paths to reach the receiver, so this is what called as multipath propagation. I hope these and all are clear for you. The next thing what we are going to see is shadowing and fading. This shadowing and fading we will see detail in the next coming slides. So now let us see what is shadowing. Shadowing is defined as the effect that the received signal power fluctuates due to the objects obstructing the propagation path between transmitter and receiver. To understand this better, so whenever the received signal power fluctuates because of any obstacle that which is obstructing the propagation path between transmitter and receiver. So this is what we call it as shadowing. So to understand this better, we will just pictorize this concept. Look here. We have a transmitter and we have an obstacle which is nothing but an object like building, and then we also have a receiver. So obviously let us consider that he is standing at point A and he will eventually consider the user is moving in this direction, so that I have taken each and every point as A, B, C and D. So now let us try to measure the signal power, that is the received signal strength when the user is at point A and when the user is at point B, C, D, etc. So what happens is when the transmitter radiates the particular signal, see, when the user is at point A, there is no obstacle between transmitter and receiver. So the receiver could be able to get good signal strength. So when he is at point A, the signal strength will be good. Similarly, when the user moves with a certain distance and he reaches at point B or point C, now what will happen to the signal strength? The signal strength is going to get greatly affected by because of the obstacle which is present between the transmitter and receiver. So my receiver will be able to get the signal but with reduced signal strength. That is, the signal strength will not be as strong when the user is at point E. After that, when he moves on to the point D again, the signal strength will be increased. So when we put this in a scenario of graph, taking position in x-axis and received power in y-axis, we could see that when the user is at point A, he could receive high signal power, and when he is at point B and C, he could receive only less signal power, and when he reaches the point D, the signal power is again getting increased. So this particular fluctuation, that is, there is an increase in signal power, there is sudden decrease in signal power, and again there is an increase in signal power. So this fluctuation is because of the particular obstacle, that is building, which is present between the transmitter and receiver. So this fluctuation is concept is what we call it as shadowing. So I hope you are clear with what is shadowing is. Now let us see about a very important term, that is fading. So before getting into the technical context of fading, let us see fading with some real-time example. which we have already came across in our day-to-day life, and we will try to correlate that example with the technical things. So I think that it will be easy to understand the concept. So generally, what do you mean by fading? Fading is generally referred to as gradual loss of certain quality or parameter. So gradual loss of certain parameter means which merely disappears over a period of time. So in order to understand this even better, let me take an example that we use in our daily life. That is, let me take an example of jeans pant. So whenever you buy a new jeans pant, that is not a faded one, a proper jeans, you could see the rich color of the particular fabric. That is, the fabric feels too good, and as well as the color will also be so rich. And eventually, when the days goes on, you could see that the same jeans pant will be able to losing its, it will be losing its color. That is, it will get faded. I hope you're getting me or getting the point. Yes, exactly. So this particular context or this particular concept is what we call it as fading. So this we have seen in our day-to-day life. So this is nothing but there is nothing doubt in this. So how this is happening? So this parameter of gradual loss of certain quality or parameter I said, right? Here the parameter what we consider is the color of the fabric. So when you notice the color of the fabric, you could see that the color of the fabric is eventually faded. It will be getting lighter, and by the days going on, you will also have a different color, which is entirely different from the day one which you have bought the pant. So what could be the reason? Can you tell me? There is no one single reason for this fading which is occurring. There are quite lot of reasons such as hardness of the water, that is whether you are washing your clothes in hard water or soft water, that will contribute for causing the fading. And also where you dry your clothes, either in shadow or in sunny area. So all these are the things which are contributing for the fading of jeans. And similarly, it could be the temperature of water as well. That is whether you're washing your pants in hot water or cold water, like those things. And the other contribution is what detergent you are using. That is hardness of the detergent will also contribute for the causing of fading of jeans pant. So these are all the various variables or various reasons which are contributing for the fading pant. So I hope you now understood what exactly the fading is. We will see the technical definition of fading in wireless communication in the next coming slide. So I hope you understood the example which I used for fading. Now let us try to put these concepts in technical terms. So in order to understand the fading over here, the definition of fading in wireless communication is fading is the variation of the attenuation of a signal with various variables. The variables may include time, geographical position, radio frequency. In wireless system, the fading may either be due to multipath propagation, weather may be particularly late. So as you all know that the signal will get attenuated whenever it travels over long distance, or it also gets faded when it gets heated on certain material. So this variation is what we call as fading. And the variables which means the contributors of this particular fading is it may be time, so your signal may get faded over time, and it can be geographical position, which means the distance as well, and similarly the frequency what we are using. So these are all the various variables I could say that are different contributors for fading. And in wireless system, the fading may be either due to multipath propagation or weather. So let us see that. So here, first one. So what is something? This is what called as path loss. So path loss is nothing but, see here. Let us consider the first one, that is blue color one. You could see that there is a transmitter over here, and the receiver is placed very nearby to the transmitter, so that you will be able to get a very good signal strength at the receiver. That is, the signal is not going to get attenuated anyhow, since the distance is very low. However, when the distance between the transmitter and receiver is increased, you could see that there is a significant drop in signal strength. That is, follow the orange color. Now see the green color. The distance between transmitter and receiver is further increased, and obviously the signal strength will also be very less. So this scenario you can also observe in the classroom environment as well. When the teacher is speaking from the stage, people sitting at the front row will hear at the louder noise, and the people sitting at the back could able to hear only reduced sound level. So it is because due to the lot of attenuation factors in the hall, like fan, noise in the corridor, and people murmuring. So all these are the factors attenuating my signal. So this is what something called as path loss, and few more other contributors are also there. That is rain, frequency, and obstacles between transmitter and receiver. So the rain parameter, you could have observed that when it is raining heavily outside, you could not able to enjoy your TV shows when you are using DTH at your home. So why means this EM waves will absorb all the water droplets in the atmosphere. So the rain will heavily affect the transmission of EM waves. So rain is one among the factor. And similarly, the frequency that you will use also causes fading, that is low frequency signal or high frequency signal. Depending upon low or high frequency signal, your signal may get faded accordingly. And the other contributor is obstacles which are present between transmitter and receiver. I hope this fading concept is clear. Thank you all.